Hello, good evening, everyone. So let's start the discussion on the previous week content for the characterization of construction materials course. There's some issue with my laptop and the charger, so I'll try to wind up the session soon, and also I'll try to record the session as well. Okay, so without further ado, let me share the screen. Okay, is my screen visible? I hope it is visible to all of you. Okay. Okay. Thank you, Pratiksha. Fine. So, okay, let's move to the first question. Arrange the following components of the LC3 binder in the increasing order of their typical percentage in the composition. So, in the last week session, we had both LC3 binder discussion and also the application of several characterization techniques in several compositions, motor compositions, and also we had to deal with image analysis. So, this question is from the initial portion, that is regarding the discussion on LC3 binder. So, the question is to arrange the following components of the LC3 binder in the increasing order of their typical percentage of composition. Option A, gypsum, calcine clay, limestone, and clinker. Option B, clinker, limestone, calcine clay, gypsum. Option C, gypsum, limestone, calcined clay, and clinker. Option D, limestone, gypsum, clinker, and calcined clay. I hope the screen is visible and then you can listen to what I'm speaking. So, what is the percentage composition of each of these components in LC3 binder? LC3 binder is limestone calcined clay cement. Okay, as I told before, I have to rush up this session because of this technical difficulty. So, let me move to the answer. Okay, the correct answer is option C, that is gypsum less than limestone less than calcine clay less than clinker. So clinker constitutes about 50 percentage of the LC3 binder, less than that is calcine clay about 30 percentage, then comes limestone, that is 15 percentage, and then comes gypsum, that is just 5 percentage. Okay, so I hope that is clear. I'll move to the next question. For the information of the newly joined attendees, I'll be rushing up this session, but I'll cover everything. Why? Because there's some technical difficulty happening, a power fluctuation and laptop issue. So let me go through all the questions. The additional hydration products formed by the reaction of excess C3A with the additional limestone present in the LC3 system. So LC3 is limestone calcined clay cement. So as the name suggests, it has an additional limestone content there. So that excess limestone reacts with the C3A and forms some additional components which does not normally occur in the case of OPC. So, what are those additional components? Option A, ettringites and monosulfates. Option B, stratlingite and ettringite. Option C, monocarboaluminates and hemicarboaluminates. Option D, monosulfates and gypsum. So, what are the additional products which form when the limestone reacts with the C3A in LC3 system? Can you please put your answers in the chat box so that we can cover all the questions, or else we have to just rush through this session. That's it. I'm extremely sorry for this difficulty, but please try to respond so that This is easier for you and me. Okay, let me move to the answer. So the correct answer is option C again. So they are monocarboaluminates and hemicarboaluminates. So this is, if you just think, what is limestone composed of? It is calcium carbonates. So there has to be a carbonate component. And also I have told that the limestone reacts with C3A. So it has to be something with the aluminates. So if you just give a basic thought on the question, you could have answered this. That is mono carboaluminates and hemicarboaluminates. Again, let me tell you, there's nothing wrong in putting the wrong answer. Just put your opinion so that we can move forward. Some other questions from week 8 content or week 9. The content which is covered in the image analysis and LC3. Week 9. That is in week 9. Coming to the next question. Efficient calcination of clay results in the disappearance of XRD peak corresponding to kaolinite. State true or false. So, clay we normally use is kaolinite clay. So, when you calcine that clay, the kaolinite peak tends to disappear from the XRD diffractogram, X-ray diffractogram. So you have a kaolinite clay and you increase the, or you calcine the clay or increase the temperature by calcining the clay. Then there is a disappearance of the kaolinite peak from the X-ray diffractogram. Is that a true statement or a false statement? Please respond in the chat box, else this will be just like a monologue. Doesn't matter whether it is a right answer or a wrong answer. There's no point in taking the live session. I can simply upload the PPT. Okay, I move to the answer now. The correct answer is true. That is the kaolinite peak. You can see this peak. These peaks are corresponding to the kaolinite. So those peaks are absent in the calcined clay XRD. So the top one, this is a blue or black peaks or the lines, corresponds to the raw clay. When you calcine it, it becomes a calcined clay, and that peak is given in the red line. Okay, so here there are these peaks are absent. Those are corresponding to the kaolinite. Moving to the next question. Class F fly ash consumes more portlandite in a cementitious binder system compared to the equal amount of calcined clay. Suppose you have a cementitious binder system, you add 15 percentage of class F fly ash and 15, and in another system you add, instead of class F fly ash you add calcined clay. So the statement states that more portlandite consumption is by class F fly ash. Is that a true statement or a false statement? Please try to respond. I don't know. This content was actually taken in the weeks, right? Can someone respond? I'm because no one is responding in the chat box, so I'm a bit confused. Because I saw the video and this was taken. Was those videos not available to you?
Video is available, ma'am, but I had just started looking the week 9 content.
But already this is week 10, right?
No, ma'am, this is week 9. Week 10 content, week 9 assignment is going to submit on next Wednesday.
I
That is
understand.
responsibility itself.
So this is related to image analysis, right? The week is related to image analysis, no?
Yeah.
Okay.
Anyway, you continue, ma'am. It will be helpful for for our
I'll
week 9
anyway
assignment.
Fine, fine. Pratiksha and man, I understand. So it's fine. I'll just go through the questions. It will be beneficial for you in the when you see the videos at least.
Ah, okay, ma'am.
Okay, so the correct answer is option B. So if you see these two graphs, graphical representations, we can find out that this is corresponding to fly ash. This is corresponding to LC3. So Portlandite is by the square, black square. So this is a Portlandite content after 28 days of hydration. So about some 14 percentage, weight percentage is retained in the Fa30 or fly ash replaced composition. When you replace it with LC3 or calcined clay, you can see that the Portlandite consumption is very high. Only 6 percentage, less than 6 percentage is retained in the system. So, which means that more Portlandite is consumed by LC3 and not by fly ash. So, the statement says that the class F fly ash actually consumes more Portlandite, which is wrong. LC3 consumes more Portlandite. So, that is represented in these two graphs. Okay, let's move to the next question. Arrange the following hydration products in the increasing order of their volume filling capacity. Ettringite, carboaluminates, CSH, then CSH, carboaluminates, ettringite, then carboaluminates, ettringite, CSH, or ettringite, CSH, carboaluminates. So when you hydrate cement, it forms hydration products. If you hydrate equal amount of each of these, the volume filled by each of these components are not the same. So some component will be more filling, volume filling. Some other component will not be filling that much of a volume, right? So which has a highest of the volume filling capacity? You have to and arrange in the increasing order of their volume filling capacity. So, to answer such questions, you have to look into the density of the components. So, here the density of ettringite is 1.8 gram per cc, carboaluminates is 2 gram per cc, CSH is 2.2 gram per cc. So, as density increases, so the density is mass by volume, right? So, if the density is more, that means the volume filling capacity is less because volume is in the denominator. Density is mass by volume. So, higher density phase will be filling only lesser volume. So, CSH will be filling lesser volume followed by carboaluminates and more volume will be filled by ettringite. That is why when we say when ettringite forms, there is a volumetric expansion. More volume is formed by the ettringite or filled by the ettringite. So the correct answer is CSH less than carboaluminates less than ettringite. Okay, let's move to the next question. Amount of limestone on the LC3 mix governs the formation of carboaluminates and hemicarboaluminates in the system. So, LC3 mix means it has limestone, calcined clay, cement. It's a limestone, calcined clay, cement. It has limestone, calcined clay, gypsum. Okay, and clinker. So, here, based on the limestone content in the LC3 mix, the monocarboaluminate amount and the hemicarboaluminate amount varies. State true or false. Okay, so let's move to the answer. It's a true statement. Why? Because more limestone meaning more calcite is introduced into the system. As I told in the first question, when there is more calcite, they will react with the aluminates forming monocarboaluminates and hemicarboaluminates. So the amount of limestone actually governs the formation of monocarboaluminates and hemicarboaluminates. Okay, just move to the next question. The alumina to silica ratio. Something happened. The alumina to silica ratio in stratlingite is dash. So stratlingite is a phase which has alumina, silica, calcium, hydroxides, etc. So what is the alumina to silica ratio in stratlingite? So the correct answer is D, that is alumina to silica. It is a we say cash, CASH. Ca is CaO in the chemistry notation, or in the cement chemistry notation. C is CaO, S is SiO2, A is Al2O3, H is H2O. Right. So Stratlingite has a formula of CaSH. So alumina to silica ratio is 1. Moving on to the next question. In the X-ray diffractogram, the Stratlingite forms its initial peak at 36 degree, 10 degree, 26 degree, and 7 degree. I guess this is a very theoretical question, so I'll move to the answer. So, stratlingite is a phase which has alumina and silica. Now, we learnt that the alumina to silica ratio of stratlingite is 1, and the initial peak of stratlingite it forms around 7 degree. That's option D. Okay, let's move to the next question. In LC3 systems, as the curing temperature increases, Portlandite consumption also increases. So, this is common for any system. Temperature increases, reactivity increases. So, let it be LC3 system or OPC system. Temperature increases, reactivity increases, and basically, in the case of LC3 system, we have limestone, calcined clay, and especially the calcined clay consumes more Portlandite that we have seen in the previous questions, right? Fly ash compared to calcined clay consumes only less amount of Portlandite, whereas calcined clay consumes more Portlandite. So that consumption is even increased at a higher temperature. So the correct answer is true. LC3 systems they consume more Portlandite and it is even increased at a higher temperature. Let's move to the next question. Now choose the correct statements. As you are now just reading or going through the week content, I'll read out and then explain. Stratlingite forms in the LC3 mortar systems even in the presence of Portlandite. This is a wrong statement because what is stratlingite is a CaSH phase. It has a alumina to silica ratio of 1, and we learned one more thing about stratlingite. It forms its initial peak in XRD at 7 degrees Celsius. Now, this stratlingite cannot form in the presence of Portlandite. Only if all the Portlandite is consumed, then only the stratlingite formation happens. It's very interesting, right? You cannot have a Portlandite and stratlingite system. Once the Portlandite has been consumed, stratlingite starts forming. So the first statement is a wrong statement. Now, option B, as the percentage of limestone in the LC3 mix increases, stratlingite formation also increases. This is a wrong statement. It actually does not happen like that. Percentage of limestone increases and stratlingite formation increases is a wrong statement. Now, third one is porcelainic reactivity can be assessed by the analyzing the Portlandite consumption. This is a true statement because we just compared fly ash and calcined clay. Which one did consume more Portlandite? Calcined clay. So, calcined clay has a higher porcelainic reactivity compared to fly ash. So, if you want to compare the porcelainic reactivity of two materials, you can look into the Portlandite consumption. Then, one which is consuming more Portlandite can be considered to be having a higher porcelainic reactivity. Now, the last statement is hemicarbonate formed in the LC3 systems get converted to monocarbonate in the presence of calcite. This is a true statement because hemicarbonate you can just imagine like a half carbonate, and monocarbonate you can imagine like one carbonate. Monocarbonate is one carbonate. So, if there are more calcites or calcium carbonate, it is easier for the hemicarbonates to get converted to monocarbonate because hemi is half carbonate. We need more carbonates to make it into one. So, in the presence of calcite, more carbonates are present. So, hemicarbonate can easily convert to monocarbonate. So the correct options are option C and option D. Let's move to the next question. Have you gone through image processing or no? Have you guys gone through image processing? Okay. Hmm. Then this is going to be difficult. So let me just stop the screen sharing. 1 second. Okay, let me ask you one more question. Is the second part of microscopy, that is scanning electron microscopy, covered in this live session? Can someone respond, please? Is the second part of the microscopy techniques, that is scanning electron microscopy, etc., is it covered in this live session? It's already covered. I'll just share the screen. 1 second. Then let me know if that content has been taken. Okay, because I'm just being confused because you told that image analysis currently you are going through. Let me see. Is the screen visible to you? Yeah. So this content was covered. Was this content covered?
This is the content of week 8.
Yeah. So week 8, was this covered? I'm asking. No, right?
No, I guess.
Okay. Anyway, I'll go through this one so that you will be more familiarized than the image analysis part. Again, sorry for the technical error. I'll try to finish it off very fast. Please try to respond also. And let me see. I have very less percentage left. Fine. No problem. I'll upload the PPT as well. Okay. Okay, so now the question is, in the scanning electron microscopy, it ensures that the electrons move following a pattern on the specimen. Dash in the scanning electron microscope ensures that electrons move by following a pattern on the specimen. Is it condenser lens or projection lens or scanning coil or electron gun? Is it the content? Okay, scanning coil. Thank you, Pratiksha. We'll move this fast because of the technical error, but I'll ensure that you are not losing any of the content. Thank you. So, correct answer is option C. Name the three major results of the electron interactions with the specimen. So the electrons in the scanning electron microscopy, they interact with the specimen and three major types of interactions are present. Can someone unmute and share what are the three major interactions happening? Can you please unmute because typing will take time and I don't want you to lose any content because of the technical difficulty here. Okay, let's move to the answer. The answers are secondary electrons, backscatter electrons, and X rays. Now, in scanning electron microscope, the size of the electron beam falling on the specimen is controlled by condenser lens, scanning coil, aperture, or electron gun. The size of the electron beam. So just imagine a small electron beam coming and hitting the specimen. interacting with the specimen. What controls the size of the electron beam? Someone in the chat box? Okay, no response. The answer is option C, that is aperture. So it is a small electron beam. Whatever the size be, it has to be controlled by the aperture. Aperture controls the size of the electron beam falling on the specimen. Moving on to the next question. Smaller the aperture, higher the resolution of the image obtained through scanning electron microscopy. State true or false. Smaller the aperture, higher the resolution of the image obtained through scanning electron microscopy. Okay. The correct answer is true, because as the aperture size decreases, size of the electron beam falling also decreases. So even the smallest detail of the specimen can be captured. So I hope you can visualize. Suppose the aperture is very small and the electron beam falling through it will be very small. So only a small area can be covered by that electron beam. So the good part is that all the small details can be captured when one beam just falls on that small area, which means that the resolution will be higher. So the correct answer is true. Okay. The Venelt cap, which controls the electron movement from the filament in an scanning electron microscopy, has dash potential. So, electron gun ejects the electrons, and there is some setup known as a Venelt cap. It controls the movement of the electron. It has dash potential. The correct answer is negative. So, here is a Venelt cap, it has a negative potential. Let's move to the next question. Compared to the thermionic type of tungsten filament, the field emission type filament, tungsten filament, or the field emission type filament has higher thickness, lesser sharpness, or increased sharpness or higher density. So, in olden days, we use a thermionic type tungsten filament, that is heating the filament and emitting the electrons. But nowadays, we use the field emission type. So, the difference is that it has a higher thickness or lesser sharpness or increased sharpness or higher density. Let's move to the answer. The correct answer is option B. That is, wait 1 second. It is option C. It has increased sharpness. This is field emission. As you can see, it has a very much pointed end when compared to the thermionic type of a tungsten filament. It is very blunt end, whereas this one is more sharp. So it has a higher sharpness. It doesn't have a higher thickness or higher density. As you can see, this is more thicker, whereas this is thinner and sharper. Let's move to the next question. Choose the correct statements from the options below regarding electron microscopes. In the presence of a magnetic field, the electron undergo spiral motion. Option B, electrons touch the lens and get transmitted through them. Option C, lenses used in electron microscopes are positive elements. Focus is controlled manually. These all are terms or sentences related to electron microscopes. You have to choose which are the correct statements. Anyone? Please be fast. I don't want this session to end without recording. Okay. Let's move to the answer. So the correct answers are option A and option C. So electrons, they do not touch the lens, and the lenses used are yes, positive elements. Electron lenses can only be positive elements because they need to converge. First one is it undergoes a spiral motion. Yes, the scanning coil helps in that case. Focus is not controlled manually, it's controlled electronically. So the correct answers are option A and option C. Let's move to the next question. Match the following detector types with the information obtained through them. So column 1 has the detector types and column 2 has the informations. EDS detector, backscattered electron detector, secondary detector. And column 2 has morphology, presence or absence of phases, and contrasts in composition. Anyone? Okay. Okay, let's move to the correct answer. The correct answer is option B. That is A2, B3, and C1. Let's see. A2. That is EDS detects the phase present or absent. B3. That is backscattered electron. It shows a contrast in the composition. And secondary electron gives the morphology. Backscattered electron, if you remember the images which was discussed by the professor, it has to be polished, and it detects based on the difference in the density of the phases. So it cannot detect morphology or presence of any phase or absence of any phase. Instead, it detects a contrast in the composition. So the correct answer is option B. Let's move to the next one. Arrange the electron types in the increasing order of their depth of collection. Auger electrons, backscattered electrons, and secondary electrons are the characters which you want to arrange properly. So the question is to arrange according to the increasing order of their depth of collection. So first will come the one which is taken from the surface, then the depth increases. So what is the option? Auger electron, backscattered secondary, or secondary auger backscattered. Let's move to the answer. The correct answer is option D, as Javed rightly told. It is auger electrons less than secondary electrons less than uh, backscattered electrons. Backscattered electrons are taken from a higher depth. So least is auger electrons. Let's move to the next one. As the density of the sample increases, interaction volume decreases. State true or false. So don't worry, I'll save the recording as much as we cover and we'll end the session. Next Tuesday, we'll take the continuation of this session, okay? And image analysis. I hope that is okay for all. Is that okay?
Okay, ma'am.
So, whatever we can cover today, we'll just cover.